Daniel is a fractional CTO at Float Health and Picture Health. Previously, he was co-founder and CEO of Range, and before then, he was a staff engineer at Google. He holds a BSc in AI from the University of Manchester and an MA in Industrial Design from Sheffield Hallam University. Am I pronouncing it
Mm.
right?
Yeah,
Okay. And with that, over to you.
cool. Nice to meet you all. Okay, cool. So yeah, as you said, my name's Dan, and we're talking about AI today, which is kind of funny because I studied AI in '98 to 2001. But when I graduated, there weren't really any AI jobs, so I moved into web development and helped build Gmail, the publishing platform Medium, and then my own startup Range. So it's actually only now 25 years later that I've actually been able to professionally use AI. And I think what's really exciting is like the current round of models are the closest things we've had to general purpose AI, and it's like pretty exciting. But of course, the challenge is like these AIs are super powerful, but they're non-deterministic. So that changes how we need to build software and how we need to deploy software. And in healthcare, being wrong is it's not just a bad experience or user experience, it can impact lives. So how do we use AI responsibly? So at Float Health, we originally found it very difficult to get buy-in on the first set of AI features. I was able to build pretty compelling prototypes in literally a day, but then it took months and months to get them deployed. So to speed things up, we've started using this model called the confusion matrix, not as an ML evaluation tool, but as a decision framework that helped really change people's vague fears into concrete, manageable risks. And then that's what I'm going to talk about today is how we use it to ship AI features with confidence. So a bit about Float. So Float connects skilled hospital nurses with patients needing IV medications. Think of it a bit like DoorDash for IV. We're better, faster than traditional agencies and significantly cheaper, about 12x cheaper than hospital infusions. But it's a complex coordination. We deal with specialty pharmacies, nurses, patients, and then, of course, billing. And the referral flow is a particularly gnarly area. So we deal with legacy systems. We do have a portal, and the portal makes things a lot easier, but only about 50% of referrals come through the portal because we are dealing with um, behavior change and these legacy systems that where people prefer to use email and phone and sometimes even fax. So when referrals come in, they're often incomplete. They may not have all the information, they may miss zip codes, treatments, whatever. And historically, this has required pretty high context professional staff. And sometimes the referral comes in and they assume that the person answering the email knows who they are personally and then can infer where this request is coming from, who it's from, what location it is. So this makes the process very hard to scale, and errors cascade. So the wrong information might lead to the wrong nurse, which leads to the delayed treatment and potentially patient harm. Okay, so the opportunity here is super clear. Like this should be a pretty simple problem. Like we can extract this data and extract structure, and everyone wanted this, but there were a lot of fears about deploying AI. Okay, so I'm sure a bunch of you are familiar with the confusion matrix. So it was developed in the 50s by a psychologist, and it's designed for evaluating classification models. So it compares actual outcomes versus predicted outcomes. And today it's used by ML and data scientists to evaluate performance. So high recall means you catch a lot of the positive cases. High precision means you avoid false alarms. Um, but we decided not to use it just as an ML metric, but as a stakeholder alignment tool. So we look at each of the quadrants, and each of the quadrants have a different cost. And the false positive does not equal a false negative. So we map each to real consequences. So just to go into detail, if you're not familiar with it, the true positive means that AI extracts and processes information correctly. So essentially, the automation succeeds. True negative means it correctly recognizes it shouldn't process, and this avoids the garbage in, garbage out problem. False positive means the AI thinks it did the right job, but it extracted the wrong information or it hallucinated. And this is pretty bad and it can mean that the bad data enters the system. And a false negative means that it fails to extract information or process information that it should have, which means it could potentially ignore or reject a valid request. So what we did is we list outcomes for each case, like what are the consequences for each of these specific cases? What's the severity? What's the likelihood? And then we work to design mitigations for each of the high severity quadrants. And then once it's deployed, we actually monitor for the actual outcomes and set thresholds based on how bad we think those cases are. Okay, so back to the float referral case. So what that meant for us was the true positive is the happy path. This means the referral is processed and ingested into the system. The true negative means it wasn't really a referral or it was missing information and we reject it and flag it for follow-up. A false positive means that it extracted the wrong data, but it thought it was a valid referral. So this could mean that the wrong treatment was identified, the wrong location, administration date, or even the number of infusions. Um, and then the false negative means that it was a real referral, but we didn't process it, which could lead to unhappy pharmacy or missed business. So the true positive is pretty, is the happy path for us. True negative means we save time. False positive is pretty bad, and then the false negative is angry. So we did the analysis, and where things landed for shipping was that the false negative was annoying and bad for business. So we basically route all negative requests to manual triage. But what we found out through the analysis was that the false positives weren't actually that bad because we had downstream validation. So we would detect it later than a manual human would, but it would still be prevented from going through to the actual visit stage. So it actually ended up being a very low risk change, and we were able to ship it with confidence. So the happy path meant we were moved from an average or mean time of 20 minutes to 10 seconds for staffing. We and then the non-automated referrals end up becoming less urgent and less context is needed to handle. So instead of having an operator standing by to respond to an email within minutes, they can have an asynchronous queue that they process more slowly, which leads to better staffing utilization. And the next step of features we're going to roll out is actually going to be the agentic error resolution. So when we detect a negative case, have the AI respond and potentially reply to the referral and ask for more information or clarification. And then we're going to deploy another step after the initial AI phase. So we're going to have a critic, which will monitor the output and the evaluation, and that will help reduce the false positives and lead to this shift left detection. So instead of letting it be resolved later in the pipeline, we can actually resolve like upfront, like the human used to do. So in conclusion, it was really a mindset shift of not what if AI makes mistakes, but which mistakes matter, and then how do we catch them? Like it will make mistakes, it's probabilistic, but just like how often and how severe are they? And then the other mindset shift was stopping thinking of AI as an all or nothing, and thinking that we have to have like humans in the loop. So it's a AI human augmented workflow where happy path is AI, but then when things go bad, we have humans available to step in and we catch that. So it's not like every single referral has to be processed by AI. It's, 90% can be processed and then the 10% can fall back to manual flows. Um, so yeah, so healthcare really needs AI efficiency. There's a lot of really crazy inefficiencies in the systems here. And what we found was this matrix, confusion matrix helps transform the vague fears into manageable, specific risks. And the other big realization was that it's not really about the technological advancements. Like it was really, really easy to implement some of these things. It was really about getting stakeholder buy-in and shipping these changes safely and reliably so we could have confidence that it was performing correctly. Like literally the prototype for this was done in an afternoon. It was vibe coded in an afternoon and the end result was very close to that. So cool. Bit faster than 10 minutes, but happy to open to questions or discussion.
Go for it, Adam.
Yeah, I was just going to ask, like, could you give an example? Because we're actually doing something similar with kind of data processing, like taking data requests and then using an LLM to do processing. Like, if you could give like an example, like if you actually get a referral, like a specific referral, and then in one of those scenarios, like how you might have a system prompt, what it kind of looks like, and then how you're formatting the output. Because like we're using like a confidence threshold
Yeah.
for some like specific criteria we might try and doing prompts. So I'd be just a little curious how you're kind of trying that.
Yeah, so the the variance in the referrals is actually like kind of wild. So some might be a one line message from a pharmacy. It's like they're typing it in manually. Some might be a PDF or a structured response. And yeah, so there may be significantly missing information or the structure is wrong or the the way that they decide how to tell you whether, what the access type is, may be very, very different. So it's incredibly variable. So the prompt that we have is it's probably about 200 to 300 lines long, and it describes in pretty great depth like what information it wants to extract, and then where the information might be confusing. So, for example, like zip code might appear in the pharmacy's signature, but we want the zip code from the referral. So the LLM is actually able to like pick out the proximity of the zip code. And then we also include some additional context like treatment types. So we give the LLM like our set of expected treatment types, even though it's in the LLM's like training set. We put that in the prompt as well to make it more likely that it's able to pick out the the treatments. And then yeah, we educate it on different ways that people might refer to access types. But yeah, if there's more specifics, happy to go in more. Oh, and output, you asked about output. Yeah, so we use Gemini with structured outputs. And I was working on a different project about 18 months ago, before the structured outputs were shipped by the models, and we had to do a lot of resolution of JSON, and the JSON would often be invalid, or it'd sometimes have arrays, sometimes have strings, sometimes be an object, sometimes be whatever. So we actually had to have a whole separate pass that took the pseudo JSON that the model gave us and turned it into something structured. But now the structured outputs work really well in our experience, and also help it be more accurate. So you're less likely to get like random hallucinations.
Awesome.
So I
Sure.
wanted to go back to what you were saying about false positives, because false positives are, are insidious. And I know you touched on this a little bit, but it's really the heart of the matter here, because the problem with false positives is the system doesn't know it's a false positive.
Yeah,
And so it gets treated as a normal as a true positive, and catching it. I mean, you alluded to human in the loop, as a means to catch it, but it can get to be very difficult if it's a subtle false positive and the human has to now go through every single positive searching for that.
yeah,
So, I mean, I can think of I've used several strategies. I mean, I face this problem as well. Um, and just a full disclosure, I work in a lot of healthcare applications as well, and so I'm very
mhm.
aware of this problem. I'm curious as to going a little deeper as to what techniques you use to make it possible to capture the false positives without so burdening the system that all the efficiencies go away.
Yeah. So what we did is we basically enumerated what false positives might exist for us, and the structured outputs actually helped. So if we take the output, like that, the model output is there's optional fields. So like patient name is actually optional. Zip code is not optional. Like we need the zip code. We need the treatment type, access type. So there's a set of fields like about, there's actually only, I think there's only about 10 required fields for the initial referral, and then other stuff is opportunistic. So then for each field, like we're basically figuring out like how could the false positive, come about. So take zip code. Is the model completely inventing a zip code that wasn't in the email? Is it seeing some other type of data that it thinks is a zip code but isn't a zip code? Is it picking the wrong zip code from the pharmacy or the sender that isn't actually for the patient? And then if it does pick the wrong zip code, what is the risk? So that's, and then we did the same thing for every single one. So the treatment type as well, like does it hallucinate the treatment type? Does it come up with a treatment that doesn't exist? And in the case of the treatment type, we give it the list of treatments that we expect. We give it aliases that we're and generics as well. And then we actually validate the treatment type on afterwards as well. So if the treatment type isn't one of our prescribed treatment types that we're used to, we send it to a human to like what is this? Is this just them referring to it in a different way, or is it like actually a different treatment? So it's really drilling down and reducing it to like the smallest false positive you can think of, and then like
Yeah, yeah.
how do we resolve that? Whereas if you think about the whole thing, it's just unmanageable, and that was why we got stuck. It's like, well, what if we get this referral? Like, what if it messes up and we don't know? Like, how do we detect it?
Right. So that's quite elegant, but but it depends on a pretty constrained use case
Yeah,
where
for
you can
sure.
identify. So it's the elegant part is recognizing that you have a constrained use case so you can
Yeah.
do that. I mean, sometimes, and this is just a comment on the broader world, the use case is not so constrained.
Yeah, for
So I've
sure.
struggled a lot with that. So that's interesting. So
Yeah, so I think
so what your basic message here is if you constrain the use case, then you have a shot at automating the detection of likely false positives.
yeah.
Okay,
So there's
interesting.
there's another scenario that we're working on where it's not as elegant and not as simple as that. And the way we're currently thinking through it is essentially like a multi-step process, and using multiple LLMs, multiple agents, let's call them, to to play different roles. And what's interesting is that you can have like the agent that's tuned for extraction, which may then lead to false positives, but then you have another agent that's tuned for error detection, and you make that especially conservative. And then each step you can still get false positives, so there is a chance that you get false positives through every step of
Mhm.
the funnel, but it's reducing the percentage. And I think that the reality that we also came to is like humans make mistakes, and I was actually like as a technologist was surprised by the number of errors that are you know
People forget that.
that do
People
occur.
talk about
And
AI hallucinating and forget just how often humans hallucinate.
yeah, and we have a whole quality control team that deals with mistakes all the time. That well, our error rates are like way lower than industry average, like but still it's like higher than I would have expected as a technologist.
Okay.
Sherwin?
Yeah, I
Just
think actually one comment and one question. I think actually it's a very good example to sort of educate the clinicians because, and what you just said, basically a lot of clinicians expect the AI to be significantly better than average human, in generally speaking. But I think your approach or example, can show how they can deal with risk management as well as accepting the areas that actually could be significantly better, and while we have a solution for areas that might not be highly better than human beings. So that's good. And I think the other point on what Keith mentioned, I think constraining the problem a lot of times actually is a key to finding the practical solutions. I think actually that's a practical strategy. One question I have, Dan, and it's not exactly related to what you're doing, but I'm positive you have thought about this as you're in the development cycles. A lot of these solutions that are coming to the prod and commercial kind of stage are lacking benchmarking, meaning, let's say even for happy medium, you have a great solution, on the surface, you see some of these, referrals are, showing great results with the automation. But then 3 months later, you have some ideas about how to make it better. But you still have to make sure that, your second version or V2 meets the previous benchmark and maybe excels that. How do you, I mean, have you thought about this, and have you addressed this?
Yeah, yeah. I mean, I think we haven't faced that float yet. But I think it goes to like ironically it uses the confusion matrix for like traditional like ML evaluation, and you basically are monitoring the whole time, and you make sure that you're tracking the outcomes, and you're tracking like recall and um sorry, I'm blanking, recall and precision. And then when you roll out a model, I think the approach would be either you do a before after, or you A/B test and you do an incremental rollout. So you roll out the new prompt to like 10% of referrals, and then you like what is the recall and precision rate on those 10%, and then you get confidence that you can roll it out more broadly.
So is it
can we take a
more
quick
covering that, the
oh, sorry.
really worst scenarios and just continuing on, or is it really confirming also that it's better than the previous version, or both?
I think it has to be both, right? But like I think we have I think what's nice about the automation of existing processes is you have historical data, and you have which you can use for training and validation. So as long as you keep that training and validation data, you can have some confidence that the solution you're rolling out is as good or like, safe enough based on the historical precedent. And then the new data coming in is just validation that it's not overfit to the validation or training set.
Thank you.
Actually, I have a follow-up question, if that's okay. Just coming to Shervin's point, like, do you have any sort of testing or implementation, like for sample data, where you run through like your existing system prompts and
Yeah.
like for different, scenarios, referral types, like treatment types, that where you can just to pre-test. So if you have a regression, like you update a system prompt to fix like a false, negative, or false positive type scenario, and then you can like readjust and test it. So, 'cause of course, the outputs can kind of adjust and change. Like we're using Gemini Flash, but I'd be also curious which Gemini you're using.
Yeah, I think that's a really good question and a good point. And one of the challenges we had, creating fake data just didn't work for us. So what we ended up having to do was create a PHI sandbox where we could run training and validation data on actual PHI without being, while remaining HIPAA compliant. So that was a bit of a pain. But yeah, because the real world data is just like so messy, and we couldn't even, mock out the fake data. And then yeah, we're using Gemini Flash as well. And when we did update the model, we did find that we have to change the prompt significantly every single time we update the model,
Got it. Makes sense.
which is mildly annoying. And I think one of the big problems and becomes I haven't come across this in healthcare, but some other people I've talked to, the ability to adapt to new models becomes a competitive advantage. So the anecdote I was talking to someone about was actually in the sort of entertainment stroke kind of like visual creation space. And if you can respond within 24 hours to a model change, you're ahead of the curve, and then people want to try you instead of like the competitors. So being able to respond to the new models is quickly is definitely worth figuring out how you're going to do that.
Yeah, I think that's why a lot of people have said that's the advantage of using like Open Router or something, because then you're vendor agnostic, and of course you have to be API based, but usually that's what you're doing if you're doing like workload or payload
Yeah.
based like processing.
But it's just like the downstream and the other effects, like it changes like all your test cases fail, it change like the outputs change subtly. Then you have to validate like are the changes like safe, or are they like incidental?
Yeah, exactly. Yeah. We haven't even we're just starting to do the LLM processing. We're doing it more on the marketing side.
But
Randall?
we did really like using Gemini.
Oh,
It's
sorry.
also covered by the Google BAA, so we didn't have to build relationships with other AI providers. So we've been pretty happy with Gemini. Randall.
Yeah, so I have kind of one comment on that last topic, and then I have another question for you, Dan. The comment I have is um, I struggle to understand competitive advantage when it seems like it's just if you're just thrashing, if models are coming out so frequently, that it's very difficult for a customer to stabilize if you're constantly changing kind of your outputs and they're not aligned to it. So, I can see that potentially for exploratory customers, new customers, but established, particularly enterprise and particularly in regulated industries like healthcare, I would struggle to see how that's a value add because stability and consistency is more, I would think, more powerful. But my question to you, Dan, is based on your experience in going through this process, how has your perception, your understanding, your mental model of when and where and how to use AI shifted compared to doing things manually with people or non-AI, kind of generative technologies?
Yeah, I think it's all related to actually like what the presentation, and I think people often have like an idea of what they can use AI for, and then they always I want to throw AI at the problem, but they haven't really thought through essentially like the flow chart or like how it's going to work, like what's the data flow, and they just want it to like magically do something. And then when you start like decomposing it, there's a lot of unknowns. And I think where AI works really well is when it has the context necessary to take action or to do something. And as humans, there's a lot of implicit context that we store, and implicit and tacit knowledge that we apply to situations that the AI won't have access to. So even in the referral case, like the silly example is that we know that like Bob pharmacist often emails on Friday, and when he emails on Friday, he's referring to he's processing a bunch of patients who are in the Riverside region instead of the San Bernardino region. So the human operator is applying that context and then can process the referral without asking like, hey, where are these patients from? The AI obviously doesn't have that information on the box. We throw a referral at it and it's like, I don't know where this patient's for. So I think we have to figure out like what do we know? It's an epistemological question of like what do we know and what knowledge are we applying to a situation, and or the operators what are the operators applying to the situation, and then how do we get that knowledge into the AI so it can actually take action. And when things go wrong, it's because there's implicit knowledge that isn't injected into the system. And then I think it's like thinking through the false positive, which is what Keith called out. It's like how bad is the false positive and what are the consequences? And I think what I found is like oftentimes the false positives aren't that bad or they're easily verifiable. And then there's a bunch of situations where they're really bad and really hard to identify. And then I just like stay away from those for now.
My kind of follow-up there and something I'm struggling with is the kind of identifying patterns, getting trends. Kind of humans are really, 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 really good at pattern recognition, right? That's our whole biology is built towards that. Um, and so some of the things you're talking about there, I'm struggling to understand why those are unique to AI versus why they wouldn't also help a person. And if we were doing this for a person, then they would become immediately more efficient.
Yeah.
And instead, we're kind of using AI as this novel new thing, which is just reinforcing things we should have been doing already.
No, I absolutely agree. And another thing that I'm working on at the moment is AI coding, and I'm working with a VC on developing AI coding practices for their portfolio companies. And what I'm seeing is that to make AI coding agents work really well, you have to do a lot of the things that make other engineers and more productive and effective. Like you have to have good interfaces, good separation of concerns, good documentation, good understanding of what you're trying to build, like what are the use cases, what are the outputs. And I think that's totally true, and that's definitely the case. And we forget that I think this is like super fascinating actually, that a lot of the challenges with deploying AI are the same things that we struggle with when running organizations. Um, so I think it's spot on. I think in the healthcare space, what I see is that there's a lot of repetitive rote work that skilled people are doing that they don't need to be doing, and we're not getting leverage from their experience. We're making them essentially act as administrators. So how do we benefit from their judgment and their experience and identify only the cases which actually need them? So I think in Float's case, we definitely want humans in the loop. We definitely want humans helping build out care plans and making sure that the quality of care is really high. But we really don't need them taking an unstructured email from a pharmacist and turning it into the first round of the visit specification.
Yeah.
We've
Thank you.
we've completed our time. I have one question, but I'm going to email it to you, Dan, or send it to you on LinkedIn. Thank you so much. This was really nice. Quite an engaged talk and conversation. See you all next time.
Right.
Have a good one. Bye bye.
Thank you.